Hi 8th grade, this is Miss B here with lesson 6.5, and today we're going to use the Pythagorean theorem to find the distance between 2 points on the coordinate plane. Similar to what we did in lesson 6.4, what's different today is we're actually going to be calculating the perimeter of a given triangle. Let's begin by going over our do now. Find the distance between point A at 2, 3 and point B at -8, -9. Give an exact answer and an approximation rounded to the nearest thousand. So when we look at these 2-point values, it always helps if you write the coordinates one on top of the other so that we can compare the x values and the y values. So we have A at 2, 3, and we have B at -8, -9. If we were to plot these 2 points in the coordinate plane, we would notice that they form a diagonal, and we can't count diagonally on the coordinate plane to find the distance. So we're going to look at how far apart 2 is from -8. So right now we're focused on the x values. So 2 is 2 values to the right of 0 on our number line. If we have 0 here, 2 is right there, and -8 is -8 spaces, well, not -8 spaces, but 8 spaces away. 1, 2, 3, 4, 5, 6, 7, 8 spaces away from 0. So altogether, the distance from -8 to 2 is 10 units. Distance is always measured with a positive value. Distance is never negative. So these two numbers are 10 units apart. Similarly, with the y values, from +3 to -9, 3 is 3 units to the right of 0, and -9 is 9 units to the left of 0. So altogether, they are 12 units apart. And now we have our 2 legs. So we're going to go on ahead and substitute that into the Pythagorean theorem. A squared plus b squared equals c squared. 10 squared plus 12 squared, our 2 legs, will be equal to our hypotenuse squared. So go on ahead and work out this problem with me. We're going to square the legs, and we have a sum of 244, which means that the hypotenuse is exactly equal to the square root of 244. So we have our exact answer, and our approximation rounded to the nearest hundredth is approximately 15.62 units. Okay, so this is our approximation. All right, so let's take a look at example number 9. So turn to the 3rd page in your handout and look at problem number 9. So the new thing that we're going to learn to do today is to find the perimeter of a triangle in the coordinate plane. So to find the perimeter, we're going to add up all 3 sides of our triangle. If you notice, this side is 3 units long, and this side is 5 units long. So we have our 2 legs, since this is a right triangle, of 3 and 5. Because we can't count along this diagonal, we're going to use the Pythagorean theorem to find the 3rd side of the triangle. Okay, I counted too quickly. This leg over here is actually 4 units. Don't be careless like Miss B. All right, so we're going to write down the Pythagorean theorem, substitute our legs. That sounds funny. Square each term. 4 squared is 16, 5 squared is 25, and that's equal to our hypotenuse squared. The sum of 16 and 25 is 41. So the exact answer here, C, is equal to the square root of 41. We're going to leave all of our answers today in its exact form, unless it tells you to round. Otherwise, you're leaving it as a square root if you can't simplify it, if it's not a perfect square number. So now we have our 3rd side of the triangle, which is the square root of 41. So in our calculators, we're going to go on ahead for the perimeter. We're going to add 4, 5, and the square root of 41. And your final answer, you can go on ahead and round to the nearest tenths place. So the perimeter is approximately 15.4 units. And there you have it. We'll look at one more example together because there is an extra step that we need to take here. Turn to the next page, look at number 13. And similarly, in number 13, we're asked to find the perimeter of this triangle. Notice that we can only count one of the three sides. So from one end to the other end, we have 4 units. And I definitely did count that one correctly this time. Okay, so we have 2 diagonals. So we're going to apply the Pythagorean theorem to find the measure of the 2 other sides in this triangle. So there's one right triangle. You know what, let me use these straight edges so they're not so crooked. You should all be using your rulers as well. So there's one right triangle. And here is another right triangle. Okay, so again, be sure to organize your work. So we can call this guy triangle number 1, and this guy here triangle number 2. So triangle number 1, let's find the hypotenuse. We have a leg of 1 unit and a leg of 6 units equal to the hypotenuse squared. So what I'm doing right now is solving for this hypotenuse, which is one of the sides of the bigger triangle that we're trying to find the perimeter of. So we have 1 plus 36 equals c squared. 37 is equal to c squared, which means c is exactly the square root of 37. So let's do the same for triangle number 2. We have legs 1, 2, 3 squared plus 6 squared again. The distance from here to here and here to here is the same, equals to c squared. So we have 9 plus 36 equals c squared. 45 equals c squared, which means c is exactly equal to the square root of 45. So now we have the 2 other sides of this triangle. So we have square root of 37, square root of 35. So again, in our calculator, to find the perimeter, we need to add all 3 sides. So we were able to count out that the base is 4 units. We found the second side to be the square root of 37, and the third side to be the square root of 45. So go on ahead and plug that into the calculator and round to the nearest tenth. Okay, and we get 16.8 for the perimeter in triangle number 13. Be sure to show all your thinking. You must complete the rest of this handout for full credit, and you have a separate handout to complete for homework over the weekend. Have a great day.